Yeah, thank you so much for having me. I'm Fabian Woller. I'm a PhD student at the Biomedical Network Science Lab at Friedrich-Alexander-Universität Erlangen-Nürnberg. And today I would like to make some advertisement for an efficient Python statistics tool that we designed explicitly for handling large-scale heterogeneous data sets with large amount of missingness in them. And in order to justify a little bit or to give some motivation how we came up with the need to design such a tool, or maybe to also showcase you for what kind of purposes our tool can be applied, I quickly want to talk about another project during which we came up with the idea to design such a tool. And that is the so-called DiHethne project. And there we are, our goal is to build an interactive web platform for the dynamic exploration of population cohort data. And maybe some of you already know, but in such population cohort study data, you usually have quite a large set of study participants. And for each study participant, you have a quite diverse set of data that's been measured. So it usually combines both molecular profiling data, such as genetic data from genomics, proteomics, or metabolomics, but usually also in combination with some clinical or lifestyle baseline information, which we usually refer to as phenotypes. And the core of the DiHethne platform is supposed to represent all this diverse data into a joint aggregated multi-level network, or multi-omics network, you could also call it. So we essentially want to take all this tabular data and aggregate it into a network representation, which can then be used by the user for performing downstream tasks from network medicine, for example. And one of the important aspects of the platform that we're building is really to have, first of all, to have this multi-omics network generation to be somehow runnable in a, let's say, real-time fashion. So at least that maybe a user who's interested in a certain subgroup of this population cohort study, they can submit a request, they start their analysis, and after maybe 10 or 15 minutes, they have their multi-omics network set up and can perform several downstream tasks. So we, on the one hand, have this aspect of somehow being efficient enough to make this runnable in an interactive fashion. And at the same time, we have quite a lot of missing data in such population cohort studies just due to experimental setup. And in case you don't want to rely on imputation, you somehow need to also incorporate the information that's also contained in the missing data, in the structures, for performing those statistical calculations. And we saw that for actually fulfilling this purpose, it's quite hard, or it's really not possible by using existing Python statistic tools to accomplish this. And that's why we came up with our own tool, Napy, which is a Python tool, which is under the hood written in C++ and using number. And we implemented a selection of standard non-parametric and parametric statistical tests, which all have in common that they somehow, first of all, take some data matrix in NumPy array format. So, for example, either storing quantitative or categorical data. And then we essentially iterate over all pairs of variables in the input data. So in order to assess statistical associations between all possible pairs in the input. And for each pair, we compute the respective desired statistical tests. And of course, this is then an intrinsically parallel task because those are all independent computations that are happening. And so this is where we made use of shared memory parallelization using OpenMP or just using number itself in order to speed up this process here. And for a given pair of variables, we then perform pairwise missing value removal, which is some sort of a compromise between having to do imputation, as I said, which we want to avoid, or only being able to do complete case analysis, which drastically reduces the size of your remaining data if you have quite large patterns of missingness in your data set. And then for when we have considered all pairs or iterated over all pairs of variables, we then just output common test statistics values, effect sizes, and p-values, which can also be adjusted for multiple testing. And just to show you, to briefly show you how this can be used. So once you have our tool and Napy installed, you can just then easily import it in your Python script by stating import an Napy. You should have your data matrix represented in a NumPy 2D matrix. And so, for example, if you're interested in running Spearman rank correlations on this large data matrix, you just input the NumPy matrix, you specify which value encodes missingness in your data set, you specify how many threads you want to use for the parallelization, and which kind of output you want to have computed. Okay, I hope I could create some interest for the tool that we developed. In case you're interested in also seeing some benchmarking results and also maybe some further details regarding installation and how it's accessible, I'm happy to discuss this also today, but also tomorrow in more detail at poster B121. And in case you're a little bit more interested also in the first part of my presentation, so the DiHealthNet project where we are planning to employ this tool, I can also highly recommend taking a look at poster C447 at Wednesday. Thank you so much.